Our story begins about 4.6 billion years ago. The solar system was young, a swirling cloud of gas and dust. Gravity pulled this material together, forming the sun at the center. Around the sun, smaller clumps of matter collided and stuck together. One of these clumps became our Earth. In the beginning, Earth was a hot, molten ball of rock. Gradually, over millions of years, it cooled down. The surface solidified, forming a thin crust. Volcanoes erupted, spewing gases that created the first atmosphere, but there was no liquid water yet, only steam. The Hadean Eon, named after the Greek underworld Hades, was a time of intense heat and volcanic activity. The Earth's surface was constantly bombarded by asteroids and comets. These impacts were so powerful that they could vaporize entire oceans. During this chaotic time, the first continents began to form. Volcanic eruptions brought molten rock to the surface, which cooled and solidified, adding to the growing land masses. The atmosphere was thick with carbon dioxide and other gases, but it lacked free oxygen. As the Earth cooled further, water vapor in the atmosphere condensed and fell as rain. Oceans began to form, covering most of the planet's surface. Life, in its simplest form, emerged in these primordial seas. The first life forms were single-celled microorganisms, similar to bacteria. They lived in the oceans, where they were protected from the harsh conditions on land. These early organisms were able to harness energy from sunlight through photosynthesis. This process released oxygen into the atmosphere, slowly changing the planet's chemistry. The Proterozoic Eon saw a dramatic rise in oxygen levels in the atmosphere. This was due to the continued activity of photosynthetic organisms, particularly cyanobacteria. Oxygen was toxic to many early life forms, but others adapted to use it for respiration. With more oxygen available, life continued to evolve. The first multicellular organisms appeared, including algae and simple animals. These early animals were soft-bodied and lived in the oceans, feeding on microorganisms. The stage was set for the diversification of life. Section 5. The Cambrian explosion. Life gets complex. The Cambrian period, at the beginning of the Paleozoic era, marked a pivotal point in Earth's history. Over a relatively short period of time, there was an explosion of life forms with diverse body plans and adaptations. This event is known as the Cambrian explosion. During this time, many of the major animal groups we know today first appeared, including arthropods, mollusks, and chordates, the group to which vertebrates belong. The oceans became populated with creatures with hard shells, exoskeletons, and complex sensory organs. Section 6. The Paleozoic era, from fish to forests. This era is one of the most fascinating periods in Earth's history, a time of dramatic transformations and evolutionary milestones. The Paleozoic era, spanning from 541 to 252 million years ago, witnessed significant developments in the history of life and the Earth itself. It was a time when life exploded in diversity and complexity, setting the stage for the ecosystems we see today. Fish diversified and became abundant in the oceans. These early fish were the pioneers of the marine world, adapting to various ecological niches and forming the foundation of the oceanic food web. Some fish evolved jaws, which allowed them to become more effective predators. This evolutionary leap gave rise to a new era of predation and competition in the oceans, driving further diversification and adaptation among marine species. Plants colonized the land, followed by arthropods, the first animals to make the transition from water to land. These early plants, including ferns and mosses, began to transform the barren landscapes into lush, green environments, creating new habitats for other life forms. Amphibians, the descendants of lobe-finned fish, also ventured onto land, becoming the first vertebrates to do so. This transition was a monumental step in the evolution of life, as these early amphibians adapted to both aquatic and terrestrial environments, paving the way for future terrestrial vertebrates. The end of the Paleozoic era was marked by the largest mass extinction in Earth's history, the Permian-Triassic extinction event. This catastrophic event wiped out nearly 90% of marine species and 70% of terrestrial species, reshaping the course of evolution and setting the stage for the rise of the dinosaurs in the Mesozoic era. Section 7. The Mesozoic Era, the Age of Reptiles. This era is one of the most fascinating periods in Earth's history, marked by the dominance of reptiles. The Mesozoic era, spanning from 252 to 66 million years ago, is often called the Age of Reptiles. This era is divided into three major periods: the Triassic, Jurassic, and Cretaceous. Dinosaurs, a group of reptiles that evolved during the Triassic period, became the dominant land animals. They roamed the Earth in various shapes and sizes, adapting to different environments. They diversified into a wide variety of forms, from massive herbivores like Brachiosaurus, which could reach heights of up to 50 feet and weigh as much as 50 tons, to fearsome predators like Tyrannosaurus rex, one of the largest land carnivores of all time, known for its powerful jaws and sharp teeth. Other reptile groups, such as pterosaurs, took to the skies. These flying reptiles had wingspans that could reach over 30 feet, making them the rulers of the prehistoric skies. And plesiosaurs took to the air and sea, respectively. Plesiosaurs were marine reptiles with long necks and flippers, perfectly adapted for life in the ancient oceans. Birds, the descendants of feathered dinosaurs, also evolved during this time. The Archaeopteryx, for example, is one of the earliest known birds, showcasing the transition from dinosaurs to modern birds. The Mesozoic era ended with another mass extinction, wiping out the dinosaurs and many other species. This catastrophic event, likely caused by an asteroid impact, drastically changed the course of life on Earth, paving the way for the rise of mammals and eventually humans. Section 8. The Cenozoic era. Mammals take center stage. The Cenozoic era, spanning from 66 million years ago to the present day, is known as the Age of Mammals. With the dinosaurs gone, mammals diversified and filled the ecological niches that were left vacant. They evolved into a wide range of forms, from tiny shrews to giant whales. During the Cenozoic era, the continents continued to drift apart, reaching their present-day positions. The climate cooled, leading to the formation of ice caps at the poles. These changes had a profound impact on the evolution of life. Section 9. The Rise of Humans. One group of mammals, the primates, evolved into apes and eventually hominins, the lineage that led to humans. Early hominins appeared in Africa around 6 million years ago. They were bipedal, meaning they walked upright on two legs. Over millions of years, hominins evolved larger brains and greater intelligence. Homo sapiens, our own species, emerged in Africa around 300,000 years ago. Humans spread out of Africa, colonizing the rest of the world. They developed language, art, and complex societies, leaving an indelible mark on the planet. Section 10. Earth's story continues. From its fiery birth to the present day, Earth has undergone a remarkable journey of change and transformation. Continents have shifted, climates have fluctuated, and the very surface of our planet has been molded by the forces of nature. Volcanic eruptions have sculpted the land, while tectonic plates have danced a slow, relentless waltz, giving rise to mountains and ocean basins. Life, too, has not remained static. From the simplest single-celled organisms to the complex web of life we see today, evolution has painted a rich tapestry of biodiversity. The evolutionary tree has branched out in countless directions, leading to the myriad species that inhabit our world, each uniquely adapted to their environment. The story of Earth is a testament to the power of time, change, and the interconnectedness of all living things. Ecosystems have evolved, interlinked in a delicate balance where every organism plays a role in the grand symphony of life. Natural cycles such as the water cycle and carbon cycle sustain life and maintain the equilibrium of our planet. And the story is far from over. As the sun rises and sets, as weather patterns shift and seasons change, Earth continues to evolve. The dynamic processes that have shaped our planet for billions of years are still at work, and new chapters are being written every day. Earth's history is still being written, not just in the rocks and fossils that tell tales of ancient times, but also in the ongoing research and discoveries made by scientists. Paleontologists uncover the secrets of the past, while geologists study the forces that continue to shape our world. And we are all part of it. Human activities have become a significant force of change, impacting ecosystems and the climate. Our actions today will determine the future of our planet, making it more important than ever to understand our role in Earth's story. By understanding the past, we can better appreciate the present and shape the future of our planet. Museums and educational institutions play a crucial role in preserving and sharing this knowledge, helping us to learn from the past and make informed decisions for the future. If you enjoyed this journey through time, be sure to subscribe for more fascinating explorations of our universe. Join us as we continue to uncover the mysteries of Earth and beyond. And together, let's celebrate the incredible story of our planet.